Hello and welcome back guys to another Alpha Math video. In this lesson, we'll be looking at general solutions. Right, so we're starting off with a very simple few equations, and then as we progress, it will get harder and harder. I've planned to do 12 examples in this video, so it's going to be quite a lengthy video. If you feel like these initial first 4 examples are too easy, then skip past them and look at the intermediate section, which will be somewhere in the middle. And if that's also too easy for you, you can skip all the way to the end of the video. Right. So let's have a look at our first basic sort of cases of general solutions. Right. When you have cos theta equal to 0.64, you want to do the inverse of cos here to get the what's known as the reference angle. Okay, so we want to find the reference angle by saying shift cos 0.64, and that should give us an angle of 50.21 degrees. Okay, now do you remember your quadrants? Right, you know the ASTC quadrants, where we have, for example, our angle alpha, and then 180 minus alpha, and 180 plus alpha, also 360 minus alpha. I know traditionally in the formula sheets they like to use a theta, or that's normally how it is in the textbooks, but I'm using alpha in this case because I want alpha to represent the reference angle, and theta is going to be the missing angle that we are trying to solve. Okay, so to solve theta here, I'm going to say, since cos is positive in the first and fourth quadrant, I will say theta is equal to alpha being the reference angle, so that's 50.21 degrees, and I'll also say theta is equal to 360 degrees minus our reference angle, 50.21 degrees. So that's going to give us a final answer of 309.79 degrees. Okay, and that's going to be our final answer. I guess let me not forget to write the all important plus k 360 degrees, where k is an element of all integers. Okay, if that didn't make sense, don't worry, we have 11 more to go. So let's have a look at our second equation over here. 2 sine theta plus 1 is equal to 0. Well, first we'll have to solve sine theta by subtracting 1 to both sides and then dividing by the 2. So we end up with sine theta equal to -1/2. To get rid of the sine theta, I'm again going to find the inverse, right? For the reference angle, we have to take the inverse of sine. But notice this time, I'm not going to include the negative sign. Okay, don't include the sign. Just put the ratio there, which is 1/2, but don't include the sign. And instead, we're going to use the sign to find the quadrants where sine is negative. It's funny because I'm saying sine as in the function sine, and then I'm also saying sine as in the symbol plus or minus. So don't get confused between the two. We are looking at the sine here, which is negative, and sine is negative in the third and fourth quadrant. Okay, so in the third quadrant we'll have 180 plus the reference angle. In the fourth quadrant we'll have 360 minus the reference angle. Okay, so that should yield 2 answers here, which I'm going to write over here. So third quadrant, we'll say theta equals 180 degrees plus the reference angle. And in the fourth quadrant, right, theta would be equal to 360 degrees minus the reference angle. Okay, so that gives us 330. For both answers, I'd like you to write this part here, plus k 360 degrees. Remember, the reason we're using 360 is because it's a period of the sine function. The sine function has a period of 360 degrees, meaning these two answers, they happen on a loop like that. Okay, every 360 degrees. Cool. Next one. And now you can see it's getting slightly harder, okay? For this one, we'll first have to subtract 1 and then also divide by the root 3. So we get tan 2 theta minus 30 degrees equal to negative 1 divided by root 3. Okay, again, use your calculator now because we're going to get rid of the tan by doing the inverse. Okay, so that's finding the reference angle. We're saying shift tan of 1 over root 3. For tan, actually do include the negative, right? When you're working out that reference angle. Because in fact, the reference angle is going to be the answer for tan. So this is simply going to be our angle, which is 2 theta minus 30 degrees. And that's equal to whatever you get here, you know. So if the calculator says negative 30 degrees, that's what you write down. Okay, then when we add 30 degrees to both sides of the equation, this will simply cancel. That leaves us with 2 theta equal to 0 degrees. And remember, by this point, you would have already start writing plus k 180 degrees, right? Because the period of a tan function is 180. But now here, when we divide by 2 on both sides, notice that the 180 also gets divided by 2. So our answer is 0 degrees plus k times 90. Okay, right, which takes us to our next question. And here we have the square root of 2 times sine of some angle equal to 1. I'm going to divide by the square root 2 here. So that gives me sine theta plus 15 equal to 1 over root 2. Okay, when we get rid of the sine now, remember this part is what I refer to as finding the reference angle. Okay, include the ratio there, 1 over root 2, and that should give us an answer of 45 degrees. Right, so we have our angle here being half theta plus 15 degrees, half theta plus 15, and it's equal to 45 degrees. That's for the first quadrant, but it's also equal to 180 minus 45 degrees because of the second quadrant where sine is also positive. Okay, so you should always end up with two answers for cos and sine. In this case, we're dealing with the first and second quadrants. Right, now let's just solve theta further. I'm going to subtract 15 on both sides. So half theta is equal to 30 degrees. And on this side, we'll have half theta equal to, is that 180 minus 45 and minus the 15. So that gives us 120 degrees. Okay, we're going to multiply both sides by 2. So that should be 60 degrees. And for this one, 240 degrees. Also, note, this is very important. Here we have already started writing plus k 360 degrees with k an element of z. However, at this point, where we chose to multiply by 2 to get rid of the half, you also have to multiply the k 360 by 2. And so for your solutions here, you're going to add plus k 720 degrees. not K360, but K720, which is double 360. Because when we multiplied by 2 here, we also had to multiply the 360 by 2 as well. Okay,